In this video, we're going to take a look at our third case for dealing with a hypothesis test for a mean. We have two independent samples. Here we're going to say we don't know the value of sigma 1 and sigma 2, the two population standard deviations. We don't know them, but we believe they have the same value. Right? And so sometimes this is a reasonable assumption. Notationally, we have a lot of stuff that is similar. The test statistic here is going to be a t statistic again, similar to what we had in case 1. So we have a t statistic, but there's a big difference here in how we calculate our degrees of freedom. The degrees of freedom are calculated in this way. So we take sample size 1 plus sample size 2, add them together, and then subtract 2. So here what's happening is we're pooling the two samples together and using that pooled data. So we add the two sample sizes together and subtract 2 when we know or we assume that the two means are equal. Our confidence interval is calculated as shown. Right, where the margin of error is this, with degrees of freedom the same as what we had above in this section. So when we go to StatDisk, the process in StatDisk is, again, similar to what we've done in the last two cases. We're choosing mean, two independent samples, but the information that we enter into that will be subtly different. So in particular, this parallels exactly case 1. So this is just like case 1, except for we're going to have this one extra step. There's a box that says equal variances pool. We are going to click that box. And that's the only way it's going to be different from what we did in case 1. In terms of using StatDisk. And what StatDisk does is has more differences. It's t-value that's going to be output. Those t-values will be a little bit different. All right, so let's look at our example that again looks very similar. So a study was conducted on arrival delays for two different recurring flights. Flight 1, which we will consider sample 1, and flight 2, which we will consider sample 2, or population 2. Suppose that among all flights, flight 1 has a standard deviation equal to that of flight 2. This is among all flights, and so there, that one sentence says we are assuming that sigma 1 and sigma 2 are equal. Our significance level is 0.05. We are going to test the claim that they have the same mean. So claim mu1 equals mu2. The opposite is, nope, they're not actually equal. So our null hypothesis is mu1 equals mu2, and the alternative is mu1 is not equal to mu2. And yeah, let's roll over to StatDisk. So in StatDisk, I would choose analysis, hypothesis testing, and then I would choose mean, two independent samples right there. So that fourth one down, mean, two independent samples. So we've chosen that. With that, we've input our different values here. We don't have a population standard deviation for either of those, but we had all of that sample data that we had from before. We got our correct alternative hypothesis input there. Our alternative hypothesis was a not equal to alternative. The thing that is going to be different here is down in this method of analysis. Instead of choosing the no pool, which is recommended, because we are assuming equal standard deviation, we are assuming equal variances. So we're going to choose that button. And we will now evaluate. And when we evaluate, we get our test statistic. Our p-value 0.3564 is shown there. So we have our p-value 0.3564. That p-value is larger than our significance level, so we fail to reject the null. P-value is high, the null will fly. We also need to identify the confidence interval. So negative 17.352 to 6.512. Again, notice that 0 is in the confidence interval. So mu1 minus mu2 equals 0, or mu2 is equal to mu1 is equal to mu2, the two means are the same, is reasonable. We can't reject the null. Again, if we look at these values in our confidence interval and our p-values, this negative 17.352, 6.512, if we compare those back to our two previous times we've done this example, so let's focus in on just this top one, 6.512. The last time we did this example, when we had instead of 6.512, 5.855. So that's maybe not so different. Here we had 6.548, and so it only showed up as a difference in those final two values when we look back to case 1. If we didn't change that box, then our values changed really subtly, but they did change. Our p-value here, the first time we did it, was 0.3569. And this time when we went through it, we got a p-value of 0.3564. So it actually only changed in that fourth decimal place. So be really careful with what information you know, what's given to you. All right, next time we're going to take a look at how do we deal with means when instead of having independent samples, what happens when we have matched pairs. We'll see you there.